So welcome back guys, welcome back again in our CCNA journey, and this is our day 2. So in day 2 guys, we'll
Okay.
be learning about more things in networking in our CCNA journey. So guys, yesterday we talked about what is a network. A network is a group of, or like you can say group of two or more connected devices. If multiple devices are connected to each other, they will form a network, and with the help of network they can communicate. They can communicate to each other, whosoever is inside or present in that network. What kind of communication? They can share resources such as files, file transfer. They can use printer. You can have a common printer, and everyone in that network can use that printer to print something. Okay, so these kind of services like printing services and file sharing services that you can utilize with the help of network. So guys, in front of you, you can see our network diagram is there, and we'll be learning about what type how many networks are there, how many, why these computers, why these switches are connected in such a manner. Is there any particular reason, or it's up to the requirement? We learn about that guys. Okay, so you know what is a network, then you also know what is a client and server. When the devices are connected to each other in a network, few devices will be server and few devices will be acting as client. So these client can, with the help of network, can send a request to the server. What kind of request? It can be any kind of request that server can fulfill. If they send a request to a server that service the server cannot fulfill, so definitely he will not provide that service now. A server is a device that provides some service. You can say it's a computer, it's a powerful computer. What does I mean by powerful? He has like he has a better CPU, he has lots of storage for storage in it. He has more RAM. In my laptop, I am having 8 GB, 16 GB, 32 GB of RAM. But in these servers, we can have like 500 terabytes of like storage and all, and 512 RAM in it. Why? Because they are server. They are running 24 into 7 to provide some service to client, whosoever is present in that network. So we know who is client and what is server. Then we have data transmission in packet. So guys, what this topic is all about, let me tell you. So let's suppose this is your computer, and we have internet. Right now I'm drawing a cloud and I'm naming that cloud as internet. You are connecting your computer to the internet. So what can happen? All those devices which are present in internet, you can communicate with them. You can send requests, you can get reply, and you can share lots of type of data. So guys, you have, let's suppose we have a server, and this server is from YouTube's. I hope everyone have like, we all are well aware of what is YouTube. It's a website, and it's a platform basically from where you can watch video, you can do streaming and all. There are a lot of kind of service that YouTube is providing, basically related to your video and all. Okay, so guys, what happens? See, if your so what happens from the browser of your computer, you send a request. You will send a request that will travel along the internet, and that request will reach the YouTube server. And that, if the request is right, then the YouTube server will give you an appropriate reply. And that reply will also travel back from the internet and will reach you too. Like, and will, with the help of internet, that data will reach you. And now then, and what's the result? You can stream video, you can watch video. So this is how you are streaming any video from YouTube. So I wanna know something. So whatever data that you are transmitting, what do you think? The complete view. This is the complete video. Let's suppose. So guys, remember one thing. Whenever we are communicating in network, we are never sending complete data. We are never sending complete data. So before sending that data, whether it's client, whether it's a server, what they do before sending data, they will divide that piece of data into small chunk. Okay, let's suppose it's a 5 MB file. The server has divided that complete video into small chunk. Let's suppose one MB chunk, 1 MB this, 1 MB this, 1 MB this, 1 MB this, and 1 MB this. In total 5 MB. So that piece of chunks, then your computer will send each chunk one by one, one by one, one by one, and that chunk will travel across the internet, and then it will reach you. So what happens? Our computer never send the complete data at once. Whenever you are sending data, that data is divided into small, small chunk. Okay, and then these chunks are transmitted with the help of network by one, one by one, one by one. Okay, so that is the one point that you should remember. So whenever you are transmitting data, these data are divided into small small chunk. You can say packets, and then these chunks are traveling across the network and then reaching you. So guys, the chunk is complete data, the video content, and guys, above each chunk, my computer, the sender will add additional header. Will be adding additional header above each piece of chunk, who is sending and to whom we want to send data. That is the additional information we need to add on above each chunk. And when you have added the additional information, now these chunks are known as packets. So chunk is what, when your computer divided it into small small packets, like basically small small sizes. And when your computer add additional information above that data, above that chunk, who is sending, to whom we are sending, what kind of additional information, according to that thing, we are calling it as a packet. And then these packets are traveling across the internet. So this is what it is happening. So this point should be clear. Now guys,
Yeah, yeah.
we are talking about networking devices. So yesterday guys, we have started about talking about this particular thing. We have lots of networking devices. With the help of them, we are connecting devices in a network and we are building a network. For example, if you want to build a small network, if you want to build your own private network, so what you'll do, you'll go and get a networking device that is known as switch. Switch has multiple ports: LAN port, RJ45 port, Ethernet port, whatever you can say. And your computer also have these ports. So you will connect one cable, one end of that cable to your computer, and other end to your switch. And same thing you will do with your other computers. And what will happen? They will form a network. Switch is a networking device that creates, it's a logical thing that creates a local area network. What is a local network? Basically, you can say a small private network. So physical connectivity should be there. After that, you need to provide some logical addressing to tell these devices which network these to tell these devices that these devices belong to which network. So let's suppose the network ID that is representing this complete network, that is 10.0.0.0/24. This time, this is the network ID that is representing this complete network. And what you'll do, inside this network ID, we'll be having lots of unique IP addresses that we can go and assign these computer one by one. Done. After that, guys, when connectivity is there and proper addressing is there, what you can check, these devices will be able to send data to whom? To the devices, to the destination who belongs to the same network. Switch is not only providing connectivity, but he is also helping the transmission of data towards the destination. So let's suppose, now guys, we have a Cisco packet tracer. We'll be doing lab here. So what I want you guys to install this piece of software. It's a free of cost, and here you will be able to learn your networking. So see, I'll go and get some end devices, whether it's laptop, whether it's your computer. Okay, let's suppose I'm having 4 devices. So see, here you will go and search and click networking devices here, and here you can find routers, switches, hub, wireless devices, security devices. So my concern is about switches. I'll click switch here, and you can see multiple models of switches are available. So for our learning purpose, we'll select the first switch, that is 2960 model. Yes, it's a switch, but the specific model that we are working on, that is 2960. Okay, I'll go and click it and place it here. After that, guys, you need to provide them connectivity. So we have cabling section over here. See, first is networking device, second is end devices, this is component, and this is connections. I'll select the fourth one, that is lightning bolt here. For like, we know what is connectivity and all, but right now we are not aware of what kind of cables are there. So for your betterment, for the starting purpose, we'll be uh, selecting this first option, that is automatically. Okay, that is automatic. So I'll go here, I'll select this cable, I'll click here on this laptop and other end of the cable, here on my switch, click here on my computer and click here on my switch, click here on my switch and then other computer, and then same thing with the fourth computer. Connectivity is there. So guys, because we are not aware of cables and all, so for this learning purpose we'll be selecting automatic one, okay, for right now. But later on we'll be selecting our cables ourselves and then using that cables here in our connectivity. So see, after connectivity, what I mentioned, we need to provide them logical addressing. So see here, let's suppose I write down here, guys. The network that we are running here is 10.0.0.0/24. It's the network ID. So we need to go on every computer and start assigning IP addresses. I'll go here on laptop one. Guys, it's little bit different from your original computer, but what we are here for learning. So you need to find how you will assign IP address on your MacBook, maybe on your Windows computer, maybe on a Linux machine. Okay, so there definitely must be a method that will help you assign IP addresses on your computer. I'll go here on laptop. I'll select static option. We have two options, automatic and other one is static. So the static means you are manually assigning. So for the beginning purpose, we'll be assigning manually 10.0.0.1 and then we have subnet mask. For right now, we'll follow the same. Just follow me and type the subnet mask as I am mentioning right now. So with the IP address, you need to mention what is subnet mask. You will get to know about them in the upcoming session, what is subnet mask. Okay, let's close it. That's all. That's enough for this particular network, this single network. We'll go on computer B, assign statically a different IP, that is 10.02, and subnet mask 255.255.255.0. Okay, done. Then we'll go to every computer. We need to do that, guys. 10.0.0.3, 255.255.255.0, that's all. And same with computer. It's not compulsory that you should be assigning IP address in a 1 2 3 order. No, you can assign any IP that is available. For example, 10.0.0.10, 255.255.255.0. That's all. Done. Okay, now when you have done connectivity, guys, so here in packet tracer, how can you check connectivity? We have a specific command, that is ping command. What is command? We'll be learning. So guys, go and open any computer. Here you will get physical, how it is looking physically. You have configuration and we have third option, that is desktop. So in third option, that is desktop, you need to select this option, command prompt. When you click command prompt, this screen will come up. In your case, it might be darker. In my case, I have like changed the background and all, so it is white in front of you. Okay, but in your case, it might be black. It's not compulsory. So here I'll be typing a command, that is ping command. After ping, type the IP address to whom you want to check connectivity with. So right now I want to check, I'm on dot 1. I want to check connectivity with 10.0.0.4. 10.0.0.4. So by using ping command, if you are getting a reply, that means connectivity is there and these devices can communicate. So but what we can see, we are not able to communicate. We are getting request timeout. Let me see why. Because let me just see. Okay, subnet mask is right. Hey, I am on this laptop. Let's go here. Okay, because no one is dot 4, guys. This computer's IP address is what? 10.0.0. Can you check? that is dot 10, and we were trying to ping 10.0.0.4 in our command prompt. So that's why no one was there who was 10.0.0.4, so no one was replying us. But if I ping the right IP address, I'll be definitely getting a reply. Can you see that? I'm getting reply from 10.0.0.10. So basically ping is doing what? It will be sending a request message to the destination, and that destination needs to give us a reply. If we are getting a reply, that means connectivity is also there, and we can send and receive data from the destination, and we can also send data to the destination. How can you check that in simulation mode? Select simulation mode. I'll go to that PC again, type the same command ping. See here, you can see a packet is involved, a data is involved, a ping request is there. That request will travel with the help of network from one of the port of my switch. It will be received. Now switch is a smart device. Switch is not only providing connectivity, but he is also able to forward the data to the from the right port towards the destination. See, he will be sending data out from the exact port the destination is connected, not to all of the people. So see, he's a smart device. Why we are saying smart device? Because of his mechanism, how he is able to perform forwarding decision. So in your CCNA, we'll be learning about that too. How switch is doing the forwarding decision and all. So for right now, remember, switch is a networking device that is helping you to provide connectivity within a single network. So guys, what can happen? Your network can be small like this, and it can scale up also according to your need. So let's suppose you have few more computer more. So you have few more departments and all, your company grows and all. In that case, you want to have more switches in a network. So inside your network, it's not compulsory that you will be having a single switch. It's up to the number of hosts that are present in your network. Okay, so see, in your network you can have multiple switches that we learned yesterday, but you need to have some sort of connectivity between switches also, guys. Switch and switch also are connected. So see, connectivity is there. Now let's go and assign these computer IP address from the same network. IP address from the same network. So I'll go here, statically assign IP address 10.0.0.4 to him. 255.255.255.0. That's all. Let's go here, assign IP address here on this computer. Okay, desktop IP address 10.0.0.5. Okay, invalid IP address 10.0.0.5 255.255.255.0. That's all. So when I have as an IP address, I'll go up to my computer A, and I will try to check these computer whether I can send data towards dot 5 and dot 4. Yes, you can see I'm getting a reply. That means connectivity is also there, and you will be able to send data, and will also be able to receive data from the destination. So that is the case here. I'll show you here in simulation mode. So then now in this PC, again try to ping. This is the ping data. The destination IP is dot 5. And see how properly the switch is able to send data towards the exact destination, because it's a smart device. It is not only providing connectivity, but will be also able to send data if source and destination, both of them belongs to the same network. So we know for right now we learn about switches and all. So let's go and see other networking devices as well. So guys, you can see here the first networking device, that is first networking device is hub. Guys, before switches, so see, switch is a modern device. So before switch is not instantly developed. So what switch is doing right now, it was the first device that was used for the same purpose, that was hub. Hub is also a networking device, but it is the first device that is used to build a single network, not switch. Okay, so if you are drawing hub in a network, you will get to see this kind of diagram, a rectangular box and a single arrow. It was also doing the same thing. Whenever anyone want to build a single network, build their own private network, they'll go and get a hub. Hub also have multiple ports just like your switch. So you will be providing connectivity like the way I'm doing. Okay, you will be assigning IP addresses to these PC. logical addressing, okay? From the same network, these are being attached, let's suppose. And then with the help of hub, you were also able to send data towards the destination. But guys, there was some problem with hub. The problem was hub was a dumb device. Guys, he was also able to provide connectivity, and, and
Why was a dumb device? It
because
wasn't smart at the switch.
no, because of the way he was forwarding data, sir.
Okay,
Because
okay,
of
okay,
that
okay.
method, we are saying him dumb. Okay, why we are saying switch is a smart device? Because of its functioning and all. Switch is also doing the same
Okay.
thing here, but he was sending data towards the exact destination. So let me show you. Just let me go and just give you a brief. Okay, so see, I'll go and build the same network here in your packet tracer. You will get and see a hub also, guys. So see here, let's build a network here. We have few computers, and here in networking device, this time I'll select the third option, that is hub. Here we have a first hub, PT hub. I'll go and select here. I'll provide connectivity. For right now, I'll choose the automatic cable. Automatically, the right cable will be selected with this option. You do not need to worry about cabling, but you should be know which kind of cables we are connecting. Okay. Then we need to send IP address. I'll quickly go 10.0.0.1 subnet mask 255.255.255.0. That's all. We need to assign IP address, otherwise these won't be able to know who are they and from which network these are member of. And same with PC4. Desktop statically assigning IP address dot so 255.255.255.255.0. So see here, to check, to do connectivity check, what we'll do after connectivity, we can use a command prompt and type a command that is known as ping command. Ping command is basically a command that is help to check connectivity, whether we are connected with destination or not. Physical connectivity is there. Now we need to check whether data can be reached toward destination or not. So see, I'm getting reply from 10.4. Definitely, we were able to send data and we were also able to get a reply back from the destination. But guys, if I show you here in simulation, what is happening in background, if I type the same command ping, so see here, what is happening. Uh, so see what is happening. If I'm trying to check, okay, I guess I have used the same computer. So see, I'll go and ping 10.0.0.4, but this time I'll select simulation and all. So see how he's forwarding and then presenter. The data that he's sending, it is, your hub is doing broadcasting. He's sending that data to everyone. He was also providing connectivity, but to transmit data, he was sending data from all the other port, so that one thing will be clear. The data will definitely reach the destination, but other people were also receiving that. So the way it was forwarding data, that was not perfect. It was having some flaw and security reason. So they changed and have few more functionality. So the device that we are working right now, it's known as switch. Is it clear? Any doubt with that, sir?
Yes, because the switch you can choose the device, the specific device to send instead of like broadcast like what the hub does. Is that right?
Basically, for right now, you will say switch is also doing the same thing that hub was doing, but the way it is forwarding data, it is much more better than the hub. Hub
Better,
is
yeah, yeah, I see.
hub is a dumb device and switch is a smart device for right now. So we have, see, for right now you can say a hub is layer 1 device. For right now you only say layer 1. What is layer 1? We'll be talking about that. Okay, it is not intelligent, because the way it is forwarding data, it is not using a better way. Then guys, we have another networking device that is known as switch. You can see in front of you we are having a Cisco switch. You can see it is having multiple ports. These are your Ethernet port. If you go on counting, definitely it will be 48 plus. Okay, it's a layer 2 device and switches basically forwarding data with the help of which addresses? MAC addresses. So actually switch are able to read some additional information about your data. Switches are intelligent. Why? Because they have a memory and basically they can read some additional information above your data that they are receiving. Like which kind of information? Who is sending and to whom you want, whom the data should be delivered. So according to that information, they were forwarding data. But Hub was not doing the same thing. Hub was receiving and Hub was sending out data from all the other port. He was not reading anything above whatever what he was not reading the additional information in simple as that. Okay, so basically to forward data, switches using the MAC addresses. Okay, we have two types of switches. One is managed switches and another one is unmanaged switches. Both of them will be doing the same thing, providing connectivity and sending the data if the destination is within the same network. But guys, managed switch, you can do configuration and all. Like we'll be learning whatever we are learning here in CCNA, we'll be using managed switches where we can control what kind of functionality should be activated and which should be not activated. We can control that. But we have unmanaged switch also that are cheaper, in which we cannot do any sort of configuration. So we have both type of switches, unmanaged, which we cannot do any additional configuration. By all the by default settings that are there that they are coming from the manufacturer, it will be only activated. But in managed switch, we can control everything, guys. Okay. Then guys, we have other networking device that is known as a router. So see, if you have, so see here it is a different network. Let's suppose here, it's Judy's network, and let's suppose here we are having Varun's network. Okay, Varun is also having lots of computer in his network, and connectivity is also there. He has also bought a switch, provided connectivity, and for logical addressing, he'll be using a different IP address. 192.168.0.0/24, guys. Let's suppose. Okay, so this computer will be assigning IP address from the same network. Let's suppose Varun will be assigning IP addresses to these computer. Okay, that is the fundamental. Now connectivity is there, they can share data. So what happened when you want to connect two different network, guys? You don't you can also connect a cable directly with the switch, but guys, connectivity will be there, but switches won't be able to send data to other network. Connectivity will be there, but what you will see, these devices, only if PCA is sending data to within his network, they will be able to send. But if he's trying to send data from his network, from this computer to other PC that is in a different network, to a different IP address, they won't be able to deliver the data. So for that purpose, guys, we have a specific device that is known as a router. So we'll go and get a router. A router also have multiple ports. Router also have multiple ports. So what you do, one of the port from your network, basically from the switch, you will be connecting towards the router. So see, every port of router is connecting to a different network. So you can see we are having a router that is having multiple ports, three ports in front of you. So one of the port will connect to TENS network, any one of the switch in TENS network, and other port of the router will connect here with my 192's network on the switch. This is how valid connectivity. And now what will be the result? You will be able to see now with the help of router, from one network we can connect to another network, and we can not only connectivity, but data will be also traveling from one network to another, and router will do the forwarding decision how to send data towards the destination from one network to another. Router is basically a networking device that is helping you to provide connectivity between multiple networks, and not only connectivity, but he has functionality. He has functionality so that he will be able to transmit data from one network to another different network. But switches don't have this functionality. Switches can only provide connectivity within a single network and can send data if the destination belongs to the same network, not to the different network. For that purpose, you need to have a router. So in front of you guys, you can see a Cisco's router. Okay. Router is basically layer 3 device. What is layer 2, layer 1, layer okay 3? We'll get to know about that. But for right now, hub is a layer 1 device, switch is a layer 2 device, and router is the layer 3 device. Basically, switches use MAC addresses to forward data, and router uses IP address information to forward data from one network to another. So what kind of information your router will be checking? IP addresses for forwarding data. So from the port he will be receiving data. So what he can check, he will be checking IP addresses. Who is sender, who is destination. And switches will be checking your MAC addresses. Who is sender MAC address, who is destination MAC address. Okay, we have that. Guys, we have another networking device that is known as access point. Access point are basically for your wireless connectivity. But before going to access point, let's go here and do connectivity and all. So guys, see, because we have, let's suppose we'll go in and let's suppose it's Varun network here on right hand side. Let me remove the hub. Let me remove this. Okay, let me go and get a make Varun's network. We have a switch to provide connectivity within his network. And to do connectivity and all, let's suppose this is the network running here on Judy's network, and let's suppose this is Varun's network. So network ID is 192.168.0.0/24. We'll we'll learn who is assigning this network ID and how we are choosing this network ID. We'll be learning that. But we need to right now understand the fundamental thing. Okay. So here it's a different network. So different IP addresses will be there. 192.168.0.1. Subnet mask is right. We'll go to next PC in this network and assign IP address from the same network. 192.168.0.2. Okay. Subnet mask. And same here. 192.168.0.3 subnet mask, and that's all. Now to check connectivity with if their destination is, if connectivity is there is not, we can use ping. So right now I'm trying to ping within the same network. From dot 1 I'll try to ping dot 3. If I'm able to get reply, that means connectivity is also there and we can also send and receive data towards the destination. Right now what I want to connect these two different networks. So I'll show without the router and all. So see, I'll go and provide connectivity from one of the switch. Let's suppose from this switch, I'm providing connectivity to a different network. That is, you can do the cabling and all, but it is wrong. Connectivity will be there, but logically, you have done wrong thing. We have two different networks, so you definitely need to have a router. So see, connectivity is there. If I try to send data from 10's network, 192.168.0.1, so see, definitely we won't be able to get a reply. See, so you can see connectivity was there, but we are not getting reply because logically you have done wrong thing. So for that purpose, see, I'll go and get a router. This network is little bit bigger and this network is little bit smaller, but it doesn't matter. What I want to connect two different networks. So definitely which device we'll be using, I'll go and get a networking device that is known as router. We have different series of router. So for a CCNA purpose, for our beginnings purpose, we'll be selecting 2911 series router here. It's a 3-port router. I'll go and get it over here. From any of the switch, you can provide connectivity, but you want from see, a router is a networking device, and every port of router is connecting to a different network. Here on the left hand side, it's a different network. It's a big network, but it's a different single network. So what you need to do, you need to go and connect one of the cable, one of the port to this network, to any one of the switch. It's your, okay, another port of the router to a different network, let's suppose here. Now after connectivity, guys, we are doing lots of other thing also, like which doing, guys. In switches we were not assigning IP addresses, but in the case of router, not only connectivity, you need to assign IP address from these network also. So see, these are the two interface on my router, gig 0 slash 0, gig 0 slash 1. It's a to make you understand, it's a different interface. So gig 0 slash 0 is connecting to 10's network, and gig 0 slash 1 of this router is connecting to 192's network. So not only connectivity, guys, we are also assigning IP addresses on these interface. So let's go on router. So just do not learn what I'm trying to do. You will learn that in the right time. Right now, just see, we need to assign them IP addresses. So guys, I know the method how to assign IP address. I'll go to this interface gig 0 slash 0, and with the help of command I am assigning IP address on my router. I am on my router, guys. Okay, so gig 0 slash 0 here, router is connecting to 10's network. So one of the free IP you'll assign here on this interface from this network. So let's suppose 10.0.0.100. Okay, and submit mask 255.255.255.0. Then and no shutdown, guys. So you on routers, guys, we need to assign IP address just like your switch, just like your computers and all. But here we are having a different method. So do not worry. Few devices you need to assign IP address. You just need to know how to assign the IP address on router. IP address are logical way to let these people know that these are connecting to which network. So gig 0 slash 0 is connecting to 10's network. So one of the IP present that belongs to 10's network, we need to assign. Okay, and same thing we need to do here also on my routers gig 0 slash 1. I'll go here, I'll go interface gig 0 slash 1 and assign IP address on this interface from 192. Any IP address, guys, any free IP address. Here in this case, we assign that. Then no shut. You can see the red lights have gone and they are showing you green light. So router is a networking device that is helping you connect two different network, not only to multiple network according to how many ports you are having. Okay, so that it's a special networking device for this particular purpose. That is the idea. Done, guys. And after that, guys, after that, we have another networking device that is known as access point. So basically, access points are your wireless devices help to help you to have a wireless network for you. So see here, so this is TENS network, Judy's network, and here we have you have few devices like your cell phone. I'll go and select end host. You will see some smartphones here. So you have smartphones and all, you have laptops and all, which also need to connect here in this network. But these devices don't have LAN ports and all. So how they can connect? So for that, for these devices to connect in your same network, what we can do? We can go and get access point. Go and select networking devices, and here on the fourth option you have wireless. So guys, here you will get to see lots of access point. So basically I'm using home router that you are having in your home. I'll go and get that. So I'll connect one of the port of route. These home router are also having ports. So what you need to do, connect that port with your switch, and then you need to configure your let's see whether my computer is having these port connectivity or not. Okay, so for here I need to go and remove this module, your wired module, and I'll add wireless module so that it can support wireless connectivity. I'll turn it on. Okay, now I'll go here and I'll PC wireless, because it can now support. So see here, it can check the home router name if everything is working fine. And if everything is working fine, you can see your laptop will be connecting to your home router, and your home router is connected to your the same network. So this is how you can have wireless connectivity within your LAN network. So you need to have a specific device that is known as access point. Access point is a networking device that is helping you build your wireless network, wireless local area NAN. Remember that point. We have other networking devices, that is some are firewall and all. So firewall is also a networking device, but basically for security purpose. So guys, see here. Now you know connect. Now let's suppose this is my home's network. Okay, and when I want to connect my home network to internet, I'll go and get a router. One end of my router is connecting to my network, and other end of my router will be connecting to internet. And internet is a public network. Anyone can get connectivity over here. Okay, you also, me also, bad people also. If connectivity is there, they can send data to us and they can destroy us. Like they can hack us also. Na? They can send malicious virus and all. So for that purpose, I want to secure my network. I want to secure my network. I have a networking device that is known as firewall. So guys, firewall also have multiple ports. You can connect your firewall just outside your network or just inside your network. So in this case, what you can see, this is the firewall that I have attached just outside my network. So whichever traffic that is coming from the attacker perspective, so not only connectivity, guys, you also need to configure your firewall and all. After configuring, what kind of you are gonna set rules and all. Which traffic should be allowed, which traffic should not be allowed. What is traffic? Basically, you can say data. Which data is allowed and which data is not allowed. If firewall allows that data, then only that data can go towards your network. If firewall didn't allow that, that traffic will never reach your network, guys. So firewall is not protecting your complete network. Okay, remember that we have two types of firewall. We have, one is your network firewall, the one that we were talking about, that was network firewall, Cisco ASA, Palo Alto, FortiGate. And we also have host based firewall. Host based firewall is basically inside your computers. You can have firewall inside your computer in software basis. So that firewall is present inside your computer only. So it can filter which traffic is allowed to receive by you and which traffic is allowed to send from your computer. So that firewall is basically protecting your computer. But network firewall is protecting your complete network. Is that clear? Any doubt with you guys? Any doubt? So
It's okay. I understand.
we have firewall and all. Then we have other devices such as repeater and modem. Okay, so we'll get to know about these devices one by one. So that is about your networking devices. The three important networking devices that you need to know, that is switch, router, and firewall for right now. Switches are used to provide connectivity within a single network. A router is used to provide connectivity between different networks. And if you want to have security for that purpose, you need to go and get a firewall. And then you will be configuring that firewall according to your requirement. Which traffic you want to allow in your network, and which traffic you don't want to be allowed in your network. You can control that. Done. So guys, before moving further, we'll be learning about few, like, I have a small topic related to you. Let's go and see. So guys, we have types of, I'm just giving you a glimpse for the yesterday session. Yes, the next topic that we'll be learning will be types of network. So I'm just giving you a brief. Guys, the smallest network. So instead of me telling you, I'll give a homework to you. So Julie, that's a homework for you. Go and research about how many types of network are there. Types of network. Now you know what is network? Providing connectivity and all. Is it true? A network is what? Providing connectivity so that data can be shared. We have multiple types of network. Do you have idea about that, Judy? Any idea?
Yes,
Like,
yes. Yeah, they have like a local network. They have like what do you call it? Uh,
yeah, yeah, try.
God.
So we have PAN, LAN, CAN. Then we have little bigger than that is MAN, Metropolitan Area Network.
Yeah, metropolitan. Yeah, yeah.
Then we have wide area network. So we have multiple types of network. The smallest is PAN. The bigger than the smallest network is PAN. For example, with the help of Bluetooth, you are connecting your
Yeah.
mobile phone with your car. So it is also building a network na, between your phone and your car stereo, maybe your headphone. So Bluetooth is also a technology with the help of which you're creating a network. But that network is not that bigger because it has some limitation and all. So you will be forming PAN. Then the next bigger network is local area network. Then we have bigger network than LAN is CAN. The bigger network than CAN is metropolitan network, and then wide area network. So guys, I'm just giving you a brief overview. From tomorrow, guys, the next session, guys, not to, we'll be learning about types of network. It's a homework for you, Judy. Go and research about it. Go,
Okay, what stand for pen? Pen stand for what?
which one? PAN, personal area network.
Yeah. Okay, person. Oh, yeah, yeah, yeah.
Personal area network. So with the Bluetooth, what are you building, sir? Personal area network. You can see source and destination will be closer to each other. Is it true? When you build, when you are
Yes.
having a PAN, your phone, like your phone and your Bluetooth device should be nearby to each other. If these are not nearby, what will happen? PAN will not be forming. The network will be
Yeah.
not. Okay, so PAN is there, but it has its limitation and all. The range is not bigger than other networks that you can see. So the smallest one is PAN. Then you can have local area network that you can build,
Then,
that you can use, that you can build with a switch. Then we have a campus area network. A campus is there, but they are having multiple small network within that campus. So it will be forming
mm-hmm.
campus area network. Then we have metropolitan area network, a network of a city. Okay, let's suppose,
Yeah.
yeah. So let's suppose I am in Delhi, maybe in Gurgaon. So all the network that we have for Gurgaon, in Gurgaon we have small networks, home networks, offices network, cafes network, hospital network. When all these network within Gurgaon are connected to each other, they will be
Yeah.
forming a single bigger network that is known as metropolitan area network of a city. Okay, man. In technical term, we'll be saying it's a man, and the highest and the last network that you can have, that is wide area network. A network that is, your internet is a wide area network. Your internet is a wide area network. You are also connected to internet. I am also connected to internet. And what you can see, you are in United States and I am in India, but still we are able to connect to each other and share data as
Yeah.
fast as possible. As fast as possible. What if we human will travel from India to USA, guys, it will take time, 24 plus hours time. But see how fast the data is traveling with the help of network. So guys, that's all for today. The next topic will be specifically types of network, types of
Okay.
traffic and all, types of duplex mode.